Hello, wonderful physics students. Today we are going to be talking about a topic called free body diagrams. By the end of this lesson, you should know what a free body diagram is, how to draw one, and what they mean. So free body diagrams are used to show the relative direction and magnitude of forces acting on an object. So basically it's let me just draw an example. So let's say, here we are. This is Mr. Magaluk. I am standing on the ground. This is the force of gravity pulling down on me. And normal force is pointing up. So this basically shows that the arrows are equal, the force is balanced out. I am standing here, content, unmoving, and these are the forces acting on me currently. So the bigger the arrow, the bigger the force. The object we represent as either a circle, like that, or a box. It's easy. I can't draw very well at all. And this is typically how physicists represent objects. Simplify it down to a point. There's no rule to how many forces can be acting on an object. It's totally situational. If we got 500 people around this desk, impossible, and would not be social distance. Got 500 people around the desk and all pushed, we'd have 500 different forces all pushing on that desk at once. So there's really no rule to how many forces are on it. It's just situational. That's what I love about physics. There's a certain process, and once you learn the process, you look at different situations and analyze those particular situations. So let's get into a couple of example problems. You all have learned about the different types of forces, what they are and when they are occurring on different objects. So you've already learned about those, and so we're going to look at a few different examples. So the first one is we're going to push a book across a table at constant speed. So to demonstrate this, we have my new how-to book, which I'm excited to get into, and I'm going to push it across the table at a constant speed. Well, what forces are acting on the object? Well, first thing when I'm going to draw a free body diagram for that situation, I want to draw my object. And by draw my object, draw a circle or a box. Then we start to think about the forces. Well, gravity is acting all the time, force gravity. Gravity points downwards, so my force of gravity is going to go down. And we know that the book is not jumping up or going down, so the force up and down should be about balance. And the table is supporting this book. So we have a force going up, and we call it the normal force. Then we have the force from my hand causing it to move this way. So I'm just going to put it this way, force applied. Okay. And it's moving at a constant speed, so we know that if something is moving at a constant speed, the forces should be balanced because there's no acceleration. So we should have a force going in the other direction. Well, what force is this? If you said friction, you're absolutely correct, right? Two surfaces rubbing together, there is a frictional force there, and so we have force friction. All right, that would be my free body diagram for that situation. Perfect. So that is done. Now we have another example here, a marker falling without air resistance. Then we'll answer, how about with air resistance? So marker falling without air resistance. What does this marker do? It drops, right? And if you just said it falls, you're partially correct. What specifically, is it speeding up? Is it slowing down? It is speeding up. We're accelerating as we go downward. So again, gotta draw my object represented as a dot or a box. I like dots, they're easier. Boxes are just as easy. I am in the habit of drawing dots. And we have our force of gravity. Because force of gravity acts on everything in the downward direction. So that should always be an easy force to deduce. Now falling without air resistance. So we have nothing pushing up on this marker. The marker's not falling and I'm hitting it up or anything like that. So there's really no other forces acting on this particular marker at this time. Now how about with air resistance? Let's go a little deeper into this. If we say it has some air resistance, do we think the air resistance is going to be bigger than the force of gravity, smaller than the force of gravity, or the same as force of gravity? Pause the video, think about what you think, and then keep watching. If you said smaller than the force of gravity, you're absolutely correct. And let's dig into why that is the case. We know the force of gravity has a longer arrow. We know the marker is accelerating downward, and that, in this case, there's probably a little bit of air resistance. But the marker is still accelerating, so we need a bigger arrow on the bottom or an unbalanced force on the bottom to cause the marker to accelerate. Because unbalanced forces cause objects to accelerate. So, we have that. Now, I got one more example for you all. And again, if you have any questions on any of this material that I'm covering in these videos, you're not understanding, please come talk to me in class. I want to make sure that I'm clarifying. I will try to ask you questions in class to see if y'all are getting this or not. But without me being able to talk with you one-on-one right now, right here, it's hard for me to know if you're getting it during these videos. So if you ever have questions, want me to clarify something, please reach out, let me know. So last example is Physics Pony is sliding to a stop after a good physics demonstration. So Physics Pony just demonstrated something and she, is all excited. I don't know why she's a he now. They are all excited and they skid in, oh gosh, no. And they are going to skid to a stop. Skid to a stop. All right. So what forces are acting on Physics Pony once Physics Pony leaves my hand? Well, we know we have force of gravity. We know Physics Pony is sitting on the table, so we have a supportive force, which we call the normal force. Now, Physics Pony is going this way. There is an unbalanced force because Physics Pony is slowing down. And Physics Pony is slowing down because of friction, right? Physics Pony, a little paws or hooves are rubbing on the table and causing Physics Pony to stop. And so we have an unbalanced force of force friction. And once Physics Pony leaves my hand, I'm not touching Physics Pony anymore. And so Physics Pony will slow down because of this unbalanced force. All right. So my hope is that by the end of this video, you all have learned what free body diagrams are, how we represent forces from a picture point of view, This will help you as you move along in your physics career, understanding the different forces, being able to visualize the different forces. In the next lesson, we are going to learn about how to find how much unbalanced force is on a particular object, and to find what we as physicists call the net force. So look forward to that in the next video. Thank you all for watching. We'll see you next time.